Hello friends. So today what we're going to do is go over a little coding kata. And in this kata it says there exists exactly one Pythagorean triplet for which a plus b plus c equals 1000. Find the product of a, b, c. Okay, so the Pythagorean theorem is this. It's c squared equals a squared plus b squared. So what we need to do is find three numbers that add up to 1000 but also return true when plugged into this equation. Then after we find those numbers, we need to find the product of them. So it's not super hard. So I'm going to write, since we're going to have to write at least one method, I'm just going to make a couple of tests for it. So here's my testing suite. So let's just go ahead and we'll describe, I just call it math logic to end, and we'll just say what should it do? It should return true when given a Pythagorean triplet, right? And then we'll just end that, and then our test is going to say expect, and we'll just call our method triplet so we don't have to write Pythagorean. Expect triplet, we need to pass in a true Pythagorean triplet, so let's find one of those real quick. So basically a way to test small things when you're writing out your tests, just go into IRB and you can write ternary statements. So what we're going to want to try to find is something that has the properties of a squared plus b squared equals c squared. That's what we're looking for. So let's see. If you take 3 squared and you add that to 4 squared, that should equal, well, let's just see what that equals. 3 squared plus 4 squared. That gives us 25, which we know 5 squared is 25. So you can write a ternary statement to check this. 3 squared plus 4 squared is equal to 5 squared. So basically the way that this logic is going, you pass in a test right here, you put a question mark there to test it as a Boolean. Then the first, before the colon on the left, returns if it's true, on the right returns if it's false. So I just have true, false here. So it should return true, and it does. So 3, 4, and 5. Triplet for 3, 4, and 5. Dot 2 EQ true. So this test is just saying, given our method that we're going to write called triplet, if we give it 3, 4, and 5, it should return true. So let's run this, and we'll get our test to fail. Rspec sequence.spec. Okay, cool. And it failed. It has a no method error. Cool, that tells us exactly what to do. Go over here and make a method for triplet. Pass it in the arguments A, B, and C. And then our logic should be if c squared is equal to a squared plus b squared, return true. And then if not, return false. Let's run our test again. It should pass. Cool, 0 failure. So now we need to make it to where, just write another test just to make sure. It should return false when given a non-P triplet. And then this is just a matter of going back to IRB, making sure, let's just say 1 squared plus 2 squared. That'll give us 5. So we know that 5 doesn't have a perfect square. So if we just pass in, let's write a ternary statement just to practice. 1 squared plus 2 squared is equal to 3 squared, which we know to be 9, so we know this is false. True if it's true, false if it's false, and it returns false. So we know that 1, 2, and 3 isn't a triplet. So expect triplet 1, 2, 3 dot 2 EQ false. And this test should pass. Cool. 2 examples, 0 failures. So this right here, this is working fine. So now that we have a method that works fine and we've tested it and it works really good, now we can get to the meat of our logic. So we'll give it a range from 1, because we want to find these 3 numbers that add up to 1,000. So we'll give it a range of 1 to 1,000 dot each do, and we'll give that the variable name a, and then we'll give a dot dot 1,000 dot each do, and we'll set up our b, and then we'll give c 1,000 minus a minus b. And so we'll go if triplet a, b, and c, we will p all of the numbers a, b, and c. Wow, it's killing me. And then we'll put answer is equal to a times b times c, because right here it says it wants us to find the product right here. And so since all of our tests are passing, all we'll have to do is run this Ruby sequence. Cool. There it is. We know that our test runs, so we know that this is in fact a triplet. So 200 plus 375 plus 425 does in fact equal 1,000. 200 squared plus 375 squared is equal to 425 squared. That passes. And then the product of all those numbers is this 31,875,000. So, not a super hard problem, but to run through it, to write a little bit of tests, to be able to run through a couple of different lists and things like that, it's a pretty good little kata. So, hope it helped.